So here it has been asked to show that the height of the cylinder of greatest volume, cylinder is there. We uh, we have to prove that the height of this cylinder, that is h, no, it is suppose y, which can be inscribed in a right circular cone. It is being inscribed in a right circular cone. Has been inscribed in a right circular cone having the height h. So the height of the right circular cone is h, and it is having semi-vertical angle. The semi-vertical angle is alpha, and that should be is 1/3 of that of the cone. It means that y should be equal to h by 3. We have to show this. We have to show this. Y equal to h by 3. Uh, if the volume of the cylinder is highest, it should be the greatest volume. So the volume of the cylinder, if that is maximum, then y should be equal to h by 3. This we have to prove. And the greatest volume, the maximum volume of the cylinder, that should be equal to 4 by 27 pi h cube tan square alpha. This also we have to prove. So now if I tell, let's suppose the radius of this cylinder is, sorry, the radius of the cone, that is r, and radius of the cylinder is x. Then we can say that suppose we take the vertex of the cone as O, and this is A, this is B, this is C, this is D. So then here we can say that the triangle OAD, that is similar to the triangle OBC. Since why? Since this alpha is the common angle, and this both angles are right angles. Since all the angles of these two triangles are same, and since all angles are equal in these two triangles, so these two are similar. Therefore, their corresponding sides will be proportional. It means we can say that OA by OB, that is equal to AD by BC, that should be equal to OD by OC. It means their corresponding sides are proportional. It means their corresponding sides are proportional. So this OA, this will be equal to H minus Y by OB. It is equal to H. This will be equal to AD, that is X, and by BC, that is R. And OD and OC is not required. So here, from here, we can see that H minus Y, that is equal to XH by R. So Y will be equal to H minus XH by R. And R by H, that is equal to tan alpha. We can say that by using this triangle OBC. R by H, that is tan alpha. So R will be equal to H tan alpha, as we can say. So here alpha is constant, alpha is fixed, and H is also fixed. Since they are some constant given values, they are some fixed given values, so they cannot change. So Y will be equal to H into 1 minus X by R. So now, therefore, the volume of the cylinder will be equal to pi r square into, so pi x square into y, since pi r square h. So this will be pi x square into y, that is h into 1 minus x by r. So here r is also a constant. It is also a fixed value since it depends on some fixed values only. So r also is a constant. So r and h both are constants. So this volume of the cylinder, we can call it as some function v of x. So we have to find the greatest volume. So now, therefore, v of x, that is equal to pi x square, pi h x square into 1 minus x by r. So is maximum, is having the maximum value if v dash x, that is equal to 0, and v double dash x, that is less than 0. Then only we can say that x is the point of local maxima of the function v. X is a point of local maxima of the function v of x. So now therefore v dash x, that is equal to 0. Okay, so now therefore we have to find v dash x first. V dash x will be equal to d by dx of pi h x square into 1 minus x by r. So that pi h is a constant, so it will come outside of the derivative. So that is pi h into d by dx of x square into 1 minus x by r. So that will be equal to pi h into d by dx of x square minus d by dx of x cube by r. So that will be pi h into d by dx of x square, that is 2x, minus that is 1 by r into 3x square. Okay, so that should be equal to 0. So it means that 2x should be equal to 3x square by r. So it means that x cannot be 0. X cannot be equal to 0. So therefore, x should be equal to, so 3x by r, that should be equal to 2, since x is not equal to 0. So it means that x should be equal to 2r by 3. Now therefore, y, that is equal to h into 1 minus, okay. So first we have to find v double dash, sorry, v double dash x, that is equal to d by dx of this function v dash x. So that is equal to 2 pi h x minus 3 pi h x square by r. So that will be 2 pi h into dx by dx, that is 1, minus that is 3 pi h by r into d by dx of x square, that is 2x. So now therefore v double dash 2r by 3, we have to find the value of v double dash at 2r by 3, that will be equal to 2 pi h minus 3 pi h by r into 2x. So x is 2r by 3. So that will be equal to, so now this is 2 pi h minus 3 pi h by r into 4r by 3. So 3 and 3 will get cancelled, r will get cancelled. So this is 2 pi h minus 4 pi h, that is minus 2 pi h, which is obviously less than 0 since h is a positive value. Since h is a positive value. So therefore, we can say that at r equals to 2r by 3, v dash x is equal to 0 and v double dash x is less than 0. So therefore, x equal to 2r by 3 is a point of local maxima is a point of local maxima of the function v of x. Is a point of local maxima of the function v of x. Okay. So now, therefore, you can say that v of x okay, so the greatest volume, okay. So it means that v of 2r by 3 is the maximum volume, of the cylinder. So when x equal to 2r by 3, then we have to find the value of y, which is the height of the inscribed cylinder. Y, which is the inscribed cylinder. Okay. So now h will be equal to h, sorry, y will be equal to y, which is the height of the cylinder. That is h into 1 minus x by r. H into 1 minus x by r. So that will be equal to h into 1 minus 2r by 3r. So that is equal to h into 1 by 3, which is equal to h by 3. So hence, we can say that the maximum volume of the inscribed cylinder, is obtained when the height of the cylinder is 1/3 of the height of the right circular cone. It's obtained when the height of the inscribed cylinder is 1/3 of the height of the cone. 1/3 of the height of the cone. So hence proved. And it has been also asked to prove that the maximum volume of the cylinder is 4 by 27 into pi h cube tan square alpha. So that also we have to prove. So now therefore V of 2r by 3, that is the maximum volume of the cylinder. So that will be equal to, so V of x, that is pi x square, pi h x square, pi h x square. So I have to do 2r by 3 whole square, pi h x square. Since why here x is 2r by 3, pi h x square into 1 minus x by r. So into 1 minus x, which is 2r by 3 divided by r. So that will be equal to, so this is 4 pi h r square, 4 pi h r square by 9 into this is 1 minus 2 by 3. So that is 1 by 3. So 3 9s are 27. So that is 4 by 27 pi h r square. And r we have told that it is h into tan alpha. R equal to h into tan alpha, we have proved that. So therefore, the maximum volume of the cylinder V is V of 2r by 3, which is the maximum volume of the cylinder, that will be equal to 4 by 27 into pi r square, pi h into r square. So r square will be h square tan square alpha. So therefore, the maximum volume of the cylinder will be 4 by 27 pi h cube tan square alpha. Okay. So this is the answer. Thank you. So sorry, we can say that it is hence proved. Okay, this is hence proved. Okay, thank you.